All right, let's just jump right in. We're at a point where we're moving way beyond AI that just talks to us. We are now entering an era of AI that actually does things. We're talking about autonomous agents. And this is all happening as part of this massive high-stakes race to build what everyone is calling artificial general intelligence, or AGI.
And, the stakes here could not be higher. This quote from Hiroaki Kitano at Sony really puts the moment we're in into perspective. This isn't just another tech trend. No. We're talking about a fundamental shift, a change on the scale of an industrial revolution. One that's going to amplify what we're capable of in ways we're only just starting to wrap our heads around.
So here's what we're going to cover. First, we'll look at the big picture, this huge race for AGI. Then we'll zoom in on the tech that's making it all possible, AI agents. We'll get into how we even test for real intelligence, tackle the absolutely critical challenge of keeping it safe, meet the key players in the game, and then finally, we'll talk about what it means to be entering this brand new agentic era. Okay, first up, the context, because it's so important to understand that AGI isn't just happening in some lab somewhere. It is a full-blown, modern-day space race. The competition is intense, and the implications are global. So what is this finish line that everyone's racing towards? What exactly is AGI? Well, at its core, it comes down to a few key things. First is generality. This isn't about an AI that's good at just one thing, like chess. It's about performing a huge range of different cognitive tasks. Then there's performance. AGI has to be at, or even better than, human level. And here's an interesting thing. While you might be picturing a robot, it doesn't necessarily need a physical body. The real goal is a system that can learn and reason through new complex problems, just like a human can. And this pursuit has just ignited this frantic competition. I mean, we are seeing this incredible clash between academic labs like Stanford and these corporate giants, Meta, Google. They're all pouring billions of dollars and just unbelievable amounts of brainpower into being the first to cross that finish line. And it's pushing the technology forward at a really breathtaking pace. All right, now let's get into the how. The really critical leap we're seeing right now is this evolution from AI that just processes language to AI that actually takes action. This is the rise of AI agents. So the engine behind all of this is the large language model, the LLM. Think of things like GPT-4. These things are enormous. They are built on this transformer architecture and trained on just colossal amounts of text from the internet. But what's really wild is that once they get big enough, we're talking hundreds of billions of parameters, they start showing what researchers call emergent abilities. These are surprising new skills that nobody explicitly programmed into them. They just appear. So, how do you turn one of these powerful LLMs into an AI agent? Well, you take that LLM, which is basically the brain, and then you bolt on these extra components that give it the ability to act on its own. It's really the difference between an encyclopedia that just holds information and a research assistant who can go out and do things with that information. And this shows you exactly how it works. The agent runs in this continuous loop. So let's say you ask it to plan a weekend trip to a music festival. First, it taps into its memory. It remembers your budget, your favorite bands. Then it moves to planning. It breaks down the big task into smaller steps. Okay, find tickets, check flights, book a hotel, find some good restaurants nearby. Finally, it goes into execution mode. It uses tools like a web browser or a code interpreter to actually perform each of those steps. It finds out, hey, flights are cheaper on Friday, puts that new info back into its memory, and just keeps running that loop until the entire trip is booked for you. Okay, so these systems are getting crazy powerful, which leads to a huge question. How do we actually measure their intelligence? I mean, how do we know if they're really thinking or if they're just getting very, very good at mimicking patterns? And that's the absolute heart of the problem, right? A lot of the standard AI tests are basically like a trivia game. They measure knowledge. But what we really want to know is something deeper. Can an AI generalize? Can it look at a few examples of a problem it has never seen before and reason its way to a solution? This is exactly where the ARC AGI benchmark comes in. You can think of it less like a final exam and more like an IQ test for AI. It's designed specifically to measure something called skill acquisition efficiency. It shows the AI a few examples of a weird, abstract visual puzzle, and then it asks it to solve a new one. It forces the AI to demonstrate genuine, on-the-fly problem-solving skills. And this is what makes it so different, and frankly, so much harder. You see, on one side, you have your standard benchmarks. They're great at testing what a model knows. It's about knowledge and pattern recognition. But ARC-AGI, that's designed to test how a model thinks. It's all about abstract reasoning and learning on the fly, not just spitting back information it's already memorized. Of course, as these systems get more and more powerful and autonomous, we hit maybe the most important topic of all: safety. How do we build the guardrails to make sure that a superintelligence is actually aligned with human values? This is what's known as the alignment problem, and it sounds simple. How do we make sure these AI systems do what we want them to do, what we intend for them to do? But it's so much harder than it sounds. You've got to solve challenges like hallucination, where an AI just confidently makes stuff up. You have to prevent unintended goals. The classic example is telling an AI to make paperclips, and it optimizes for that goal so hard it decides to turn the whole planet into paperclips. And then you have the really big one, scalable oversight. How can we possibly supervise a system that could become way, way smarter than us? Now, to try and solve this, researchers have developed some really clever techniques. For a while, the gold standard was RLHF, but it's a complicated multi-stage process. Lately, the field has been moving towards simpler, more direct methods like DPO, or direct preference optimization. Instead of this complex setup, DPO finds a way to teach the AI human preferences directly as part of its main training. It's kind of like teaching a student good habits while they're learning, instead of trying to fix bad habits later with some complicated reward system. It's just a lot more efficient and a lot more stable. So who's actually building this future? I mean, to really understand where all this is headed, you have to look at the people and the philosophies behind the platforms. These are the new power players shaping the AI world. And what's interesting is, not everyone is chasing the exact same goal. This quote from Joelle Pineau at Cohere is really telling. She's basically saying that by focusing on building practical, traceable AI for businesses, they get an edge over the companies that are in this all-out race for AGI. It just goes to show you, there are different strategies at play here. And this gives us a great snapshot of that landscape. You've got Meta with a lab that's explicitly aiming for superintelligence. Then there's Cohere with that sharp focus on enterprise AI. Over in academia, you have powerful voices like Fei Li at Stanford, pushing for a human-centered, responsible approach. And then at Google, you have research teams building these absolutely mind-blowing new architectures designed to give AI things like infinite memory and real-time learning. Everyone has a slightly different vision for the future. So when you put all of these pieces together, the race for AGI, the new technology, the tests, the safety problems, the key players, what does the horizon actually look like? Well, the consensus is pretty clear. We're not heading towards it anymore. We're in it. The agentic era has already begun. And this is the fundamental shift. This is the big takeaway. For years, AI has been a passive tool. You ask a question, you get an answer. We are now transitioning to an AI that is an active collaborator. These are systems you can give a complex, multi-step goal, and they will work on their own to achieve it. And that changes absolutely everything about how we're going to work and solve problems.
You know, it's a change that's happening so fast, it can feel a little bit surreal. I think this comment from a Reddit user just captures the public mood perfectly. The pace of progress is so incredible, so transformative, that it honestly feels like we're living in a world that just a few years ago was purely science fiction.
And that leaves us with the ultimate question, doesn't it? This technology is here. These AI agents are going to become our collaborators, our partners, our most powerful tools. So the real question is, what are we going to ask them to do? What monumental challenges will we point them at? The answer to that question is going to define the next chapter of human history.